At this point in the course, we've looked at more than a handful of examples, and we've learned several tools that make enumerating a web application really easy. We've even gone a few steps further to begin stringing together individual vulnerabilities into a full-fledged exploitation of a web application. In this example, we're going to be looking at the machine Waldo. You can see the IP address here on the screen. As I've noted in previous examples, double check the IP address that you see on your screen if you're following along, as it may be different than mine. Waldo is going to involve learning yet another tool that we can put in our tool belt to help us further enumerate a web application and begin to learn new strategies of exploiting vulnerabilities that we find. When we're done with this example, we're going to pivot out of Hack the Box to an entirely different tool, so let's dive right in. Just like we've done with previous examples, we're going to start by running an nmap scan against this target. So nmap, let's give it a dash capital A, and 10.10.10.87. Nmap returned rather quickly, and just like in prior examples, we can see that port 22 is open, allowing SSH access directly to the server. Port 80 is open, hosting some sort of HTTP application that's hosted this time on an nginx backend. And we have a third port running on 8888. We're not entirely sure what it is. It says it's in a filtered state. It could be something called Sun Answer Book. We're not sure what that is right now, but for the moment, let's continue running through our arsenal of tools. If we know there's a web application running on port 80, the next thing we may choose to do is to run a nikto scan against this particular website. Let's take a look at what nikto returned. You can see again that nikto is reporting the same version of nginx that nmap originally told us. The nginx server is also available to run PHP 7.1.16, so almost certainly one of the first things we would do would be to go copy this and Google for if I could type. Of course, I already had that in the beginning. Vulnerabilities, and I don't know, maybe we'd find something here on CVE details. It actually doesn't look like 7.1.16 has anything publicly available, so that's great news for this box. We are missing some HTTP response headers that would mitigate some really easy cross-site scripting attacks. We're not really worried about those here on Hack the Box. Interesting, the root page redirects to list.html, so we'll want to check that out. So before we flip over to the browser, let's actually kick off a gobuster scan as well, as that's now a tool in our arsenal. So we'll do gobuster dir-u http://10.10.10.87 with a -k-w user share derby word lists common. And running gobuster, we apparently get some kind of error. So perhaps gobuster is not going to be really useful on this application, considering that there is a 3.0, I think it was a 3.01 or a 3.02 redirect from the root page to list HTML. Maybe that's throwing gobuster off here. So if gobuster is not going to be helpful, then let's just click on Firefox and pull this website up here in the browser. So again, this is http://10.10.10.87. You You can immediately see it does redirect to list.html. You can see the ability to add lists to this page. I can click on a list, go back. Looks maybe I can delete a list. So that's all very interesting. Let's take a look at the source code, and we'll start to manually enumerate what we've got here. So we do see a script tag here in the header, so I might take a quick look at that. And here's where some things are going to get interesting for us. So we do see some JavaScript that are making XML HTTP requests. Now, in some of the prior examples, we've seen JavaScript libraries like jQuery be used. So if you're not overly familiar with how web applications, especially modern web applications that are written using modern JavaScript frameworks work in today's day and age, you might not be used to seeing XML HTTP requests. So this is using the raw libraries built into the JavaScript language, allowing us to make these remote requests against other HTTP endpoints, typically from an API. And what we'll see here is that we're creating a new request. It's via HTTP post to a file called fileRead.php. You can see it sets a header, does some other things. But these are exactly the sorts of JavaScript bits that an attacker is going to focus on. They don't really care so much about a lot of the jQuery things that are controlling slideshows or executing generic JavaScript events as you click on buttons or links or interact with the web application. Attackers really care about how the data gets in and out of a web app. So they're going to look for things like the ability to post data to an endpoint, or is this going to file delete? And an attacker is going to look at this pretty closely to start figuring out what exactly the application's trying to do. Here we have another file read or a dirRead, presumably that's dir for directory. At this point, knowing that there's a lot of back and forth with an API of some kind, this is a great time to introduce a tool called Burp, which we can find in ParaDOS by going to Applications, or I'm sorry, Pen Testing, Most Used Tools, Burp Suite. And this will take a moment to fire up. I won't care about JRE warnings in this context. You can accept the terms and conditions. Don't have to worry about updating Burp right this moment. Temporary project is just fine, so we'll hit next and start Burp. So before we go any farther, it's important to explain what Burp is. Burp is what you would commonly refer to as a proxy tool. Many web application developers might be familiar with other such proxy tools as things like Charles Proxy or Fiddler. There's a great and similar tool to Burp from the OWASP organization called OWASP Zap. All of these tools mostly do the same thing. The general idea is that you have a tool that's intercepting the requests coming from your web browser on your machine. They're intercepting the requests made to a remote web server. They do this so that you can inspect all of the traffic going between your web browser and the remote machine, and they could potentially allow you to modify the requests while they're in flight. An astute observer might notice this is effectively a man-in-the-middle attack, though it's not really an attack because you are the one intercepting your own requests. Having said all of that, there are two important things we need to do in order to use Burp. The first thing we're going to want to do is to move your mouse over the proxy tab at the very top You're going to want to turn off intercept by clicking on the button. Frequent users of Burp can click into the options menu and configure intercept to always be off. But for those of you new to Burp, make sure intercept is turned off or else the website may not load. The second thing we need to do is in the browser. Here in Parrot OS, there's already a Firefox extension called FoxyProxy. This browser extension will automatically proxy the HTTP requests coming out of Firefox into Burp and then along out to the remote web server. So we want to make sure that we select Burp running on port 8080 here in FoxyProxy. The next thing we'll do is click back on the web page tab, and we'll click the refresh button. And here in the browser, nothing's changed. But coming back over to Burp and clicking on the target tab, we can now see that we have an active target displayed here in Burp. This left-hand pane is constructing a physical sitemap of all of the files and assets hosted by this application. In fact, we can see the list.html, the list.js, and even the start of some of the PHP files that we saw noted in that JavaScript file with all the XML HTTP requests. You'll notice here on the right we have a listing of all of the requests that are getting made, as well as here in the bottom, the ability to flip between the request and the response from the server for any selected request. The great thing about Burp is that we can continue to do manual enumeration of the website while Burp is collecting all of the information about individual requests, all the files and assets and HTTP headers for us so that we can come back to Burp later and review the results of what we found. It's a great way to take notes without having to manually write everything down by hand. So let's come back over to Firefox. We'll add a new list. Maybe we'll click into it. And as we're doing this, you can see in Burp, just to my left, we're adding additional files into our file tree simply by clicking through the screen. Add new items. Potentially I can click help. I can delete an item. I can delete a list. So at this point, we've seen just about all of the interactions that the Waldo website is going to allow us to do. Let's start to inspect some of these requests using Burp. Let's take a look at the fileRead file and see what parameters we're passing via HTTP post to this endpoint. Looking at the raw headers of this request, we can see that we're executing an HTTP post against the fileRead.php file via HTTP 1.1 protocol. See, it's going to a certain host. Firefox has provided a user agent on our behalf. And we can see a variety of other HTTP headers that really aren't all that interesting for this example. What we do see is a file parameter that takes what appears to be a relative file path. One thing an attacker is going to do for sure is attempt to access files they probably shouldn't have access to, hoping that perhaps this value isn't properly validated on the server. In this example, we can see a response comes back that's some sort of JSON response containing a file and what appears to be maybe a raw JSON object here represented as a string. In Burp, what we might choose to do then is to use some of the built-in proxy tools to replay this request, which you can do by right-clicking on the request, going down to send to repeater, and clicking that option, at which point you see repeater up here in our toolbar flashed orange. Clicking on this tab, we can see the raw request. I can hit send, and we get a response from the server telling us that file is false. The question might become, what happens if we attempted to execute the same request by changing the value of file? Maybe providing list2. I can then hit send, and we can now see a different response here where there's a JSON object with the word pwn in it. Perhaps I would want to change this again to list1. And we can start to see, now I'm able to further find file contents belonging to other files on the server. At least that's the leading theory that an attacker would have given an endpoint just like this. Maybe just type in dirRead.php. Type that in. And the endpoint spits out the raw contents of that dirread file, which if we scroll all the way to the right here, we can see there's quite a bit of PHP code in here. Perhaps a really easy way to do something would be to copy and paste this, put it into a PHP file, have your IDE format it for us. In the interest of skipping ahead directly to what we're looking for, you kind of read through the code. It's going to look for a variable called path. And remember, this is the dirread file. This is not fileRead.php. I actually wonder what happens if we just spit out the contents for this file specifically. See the contents for this file. So it's looking for a file parameter that's right here. It's looking to make sure it's got JSON as an accepted content type. And then it's going to do some sort of string replace, replacing any backslash characters, potentially some other dots. And you get the idea. You have to kind of study what the PHP code is doing here. But the question does become, well, is there a way to bypass this sort of string replace? So it's important to point out this sort of regular expression string replacement is very common on web servers, and yet it is fairly easy for attackers to bypass. So as an example, we were trying to do something like xxx password. And as you'll recall, it's not able to access that for us. But what would happen if we constructed an attack designed to bypass that PHP string replace function, where it's looking for characters like ... But if we were to put 3 dots before that, it's going to strip out that ... still leaving a ... in its place. So perhaps there's a way for us to figure out how to get all the way back to where xxx password ought to be. So again, taking this ... approach, maybe we want to leave 4 dots here so that when that's stripped out, it's still going back a directory. You try to construct some sort of bypass of that string replace function. See, well, that didn't quite work. I wonder if we can start bypassing some of these other things. So by piecing together a way to bypass that string replace regular expression, you can see that we're still able to access the contents of our etc password file. And in fact, we can see there might be a user of nginx on here, which is no surprise given that there's an nginx server. There's a nobody user. And the rest of these look like they're probably pretty standard. So to re-emphasize why this specific attack was able to work, the string replace is looking for ... character. So if we strip that out, we're still left with a ... at the beginning. And then it's looking for a ... And then it's looking for another ... But it's not recursively checking for what's left in the string. So it's stripping out ... but then leaving us with the remnants of that string. And those remnants still construct the ability to walk backwards in the file system until we find etc password. Burp is a fantastic tool for identifying vulnerabilities such as this, things that would be very difficult to do using many automated tools. So if we're able to read something like an etc password file where we can see a user with a home directory, let's go back to, so we had guessed and nobody appears to be a user with a home nobody. So we can come back to directory read file, send this to repeater, and maybe here we want to swap out for trying to read the contents of the nobody directory, their home directory. Where we can see there is a .ssh. We can see if there are potentially any keys on the system. So there is authorized keys. There's also a .monitor. So maybe coming back to our original file read file, maybe we can say .monitor. Oops, missing a slash here. So now we can see we've accessed somebody's SSH file. So we could potentially just drop this on our machine and then SSH directly to the Waldo server, at which point we now have user access on the server, not just a generic user of the website. So we've been successfully able to escalate privileges from a generic web user into an authorized user with SSH access to the server. Hopefully nobody isn't one of the administrators. So as you can see, Burp is an immensely powerful tool for helping us to replay HTTP requests, modifying them during our attempts to exploit vulnerabilities. It's also a fantastic tool for simply creating a sitemap to help us keep track of all of the assets we're going to run into during a penetration test, or just as we're trying to enumerate our own applications. Most web applications are going to have considerably larger file trees than what you see on the screen here, and Burp is fantastic for everyday development if you're building a web application on your own. It's a great replacement for Charles Proxy or Fiddler or any other number of tools. Burp also has a crazy number of excellent security tooling built into it beyond just the example of repeater that we've just seen. There are all kinds of plugins and extensions, and best of all, the Burp Community Edition, like you see here on the screen, is totally free and available on Mac, Linux, and Windows operating systems. If you're feeling comfortable enough with Burp and the other tools that we've explored at this point, let's go dive into a more fully fledged web application written in a modern JavaScript framework to help us continue to flex these security muscles and protect our web applications.